are being watched. Right now, as you read these words, as your heart beats and your lungs fill with air, something may be observing you, not from across the room, not from a camera in the ceiling, from somewhere impossibly far away and impossibly close. You have felt safe your entire life. You wake up, you go about your day, you fall asleep under a sky filled with silent stars. That silence has always felt peaceful, reassuring. The cosmic void, vast and empty, asking nothing of you. But what if the silence is not emptiness? What if it is patience? What if there are eyes behind those stars, eyes that have been watching your species struggle upward from the mud, watching you discover fire and split the atom, and finally begin to wonder if you are alone? What if they are waiting for something, waiting for you to prove something or fail at something before they decide what comes next? This is the question that keeps certain scientists awake at night. The question that has haunted astronomers for over 70 years. The question that may have an answer so unsettling, so profound, that most people would rather not hear it. Where is everybody? And why, after all this time, won't they answer? You grew up believing a comforting story about the universe. We all did. The story goes like this. Earth is special. We are the product of 4 billion years of random chance, of cosmic dice rolling in our favor over and over again. Life is rare. Intelligence is rarer still. And so we find ourselves alone in an empty universe, the first and perhaps only species to look up at the stars and wonder. This story feels good. It makes us important. It explains the silence. If we are alone, then of course, no one is talking back. The universe is simply a very large, very quiet house with only one occupant. There is just one problem with this story. The mathematics say it cannot possibly be true. In 1961, a young radio astronomer named Frank Drake sat down at a chalkboard at the Green Bank Observatory in West Virginia. He had gathered a small group of scientists, including a young graduate student named Carl Sagan, to discuss a question that seemed almost too audacious to ask out loud. How many civilizations might exist in our galaxy that could communicate with us? Drake wrote an equation on that chalkboard. It was simple, almost embarrassingly so. A string of variables multiplied together. The rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction where life actually appears, where intelligence evolves, where technology develops, and finally, how long those technological civilizations survive. The Drake equation, as it came to be known, was never meant to give a precise answer. It was a framework for organized ignorance, a way to identify what we did not know. But even the most conservative estimates were staggering. Consider the numbers. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Research from NASA's Kepler Space Telescope suggests that at least 25% of Sun-like stars have Earth-sized planets in their habitable zones, the orbital sweet spot where liquid water could exist on a planetary surface. A 2020 study estimated there could be as many as 300 million potentially habitable worlds in our galaxy alone. 300 million. Let that number settle into your mind. 300 million worlds where the conditions for life as we know it might exist. 300 million rolls of the cosmic dice. 300 million chances for intelligence to arise. And our galaxy is one of at least 2 trillion in the observable universe. When you multiply those numbers together, the results become almost meaningless in their enormity. The universe contains more potentially habitable worlds than there are grains of sand on all the beaches on Earth. More chances for life than any mind can truly comprehend. Now consider time. The Milky Way is approximately 13 billion years old. Our solar system formed 4.5 billion years ago, but other star systems have had billions of years more to produce intelligent life. If civilizations arise even occasionally, some of them should have had a head start on humanity, measured in millions or even billions of years. A civilization a million years older than ours is almost incomprehensible. A million years ago, our ancestors were still learning to walk fully upright. In the mere 10,000 years since the agricultural revolution, we have gone from stone tools to smartphones, from smoke signals to radio telescopes. What might another million years of progress look like? 10 million? A billion? Such civilizations, if they exist, should have had plenty of time to colonize the entire galaxy, even traveling at a fraction of the speed of light, a feat we can already imagine with near-future technology. A civilization could spread from star to star, system to system, filling the Milky Way in a few million years. An eye blink in cosmic terms. The galaxy should be teeming with life. The skies should be crowded with signals. We should see the lights of alien cities on distant worlds, detect the waste heat of their megastructures, intercept their communications bouncing between stars. Instead, we see nothing. We hear nothing. In the summer of 1950, physicist Enrico Fermi was walking to lunch at Los Alamos National Laboratory with colleagues Edward Teller, Emil Konopinski, and Herbert York. The conversation had turned to recent reports of flying saucers and the possibility of faster-than-light travel. When they sat down to eat, Fermi suddenly blurted out a question that seemed to come from nowhere. "Where is everybody?" His colleagues immediately understood what he meant. If intelligent life is common, if the math says civilizations should be everywhere, then why can we find no evidence of them? Why has no one visited us? Why do our radio telescopes hear only static? Teller later recalled that the result of his question was general laughter because of the strange fact that, in spite of Fermi's question coming out of the blue, everybody around the table seemed to understand at once that he was talking about extraterrestrial life. According to York, Fermi then proceeded to do a series of back-of-the-envelope calculations right there at the table, estimating the probability of Earth-like planets, the probability of life given an Earth, the probability of intelligence given life, and so on. He concluded that the galaxy should have been colonized long ago, and yet we see nothing. The question became known as the Fermi Paradox. And in the 7 decades since Fermi asked it, we have looked harder than ever for an answer. We have discovered thousands of exoplanets. We have confirmed that nearly every star has at least one world orbiting it. The conditions for life appear to be everywhere we look, yet the silence persists. SETI, the search for extraterrestrial intelligence, has been scanning the skies since Frank Drake first pointed that 85-foot radio telescope at 2 nearby stars in 1960. In that pioneering experiment, which Drake called Project Ozma, after the princess in L. Frank Baum's Oz books, he listened for signals from Tau Ceti and Epsilon Eridani, 2 sun-like stars within a dozen light-years of Earth. He heard nothing, but the search had begun. Over the decades that followed, SETI programs grew more sophisticated. The Allen Telescope Array observes 12 hours a day, 7 days a week. The Breakthrough Listen project backed by $100 million in funding from technology investor Yuri Milner, is conducting the most comprehensive search in history, scanning 1 million nearby stars and 100 galaxies. In 1977, a signal so strong and so unusual that it seemed to demand explanation appeared on the printout of the Big Ear radio telescope at Ohio State University. An astronomer named Jerry Amon circled the data and wrote "Wow" in the margin. The signal came from the direction of the constellation Sagittarius. It matched the expected signature of an artificial transmission. It lasted 72 seconds, and then it was never heard again. Despite repeated attempts to relocate the signal, despite decades of searching, the WOW signal remains unexplained. It might have been interference, it might have been a glitch, or it might have been exactly what it appeared to be, a brief glimpse of something artificial, something intelligent, something that chose not to repeat itself. Nothing, not a single confirmed signal, not one artifact, not a single piece of evidence that intelligence exists anywhere but Earth. The great silence, some scientists call it, and it is deafening. Now you might think, perhaps we are alone after all. Perhaps life is so rare, so unlikely, that despite the vast numbers of stars and planets, Earth truly is the only place where the cosmic lottery produced minds capable of asking questions about the cosmos. This is called the rare Earth hypothesis, and some scientists believe it. Perhaps the conditions for complex life are so precise, so dependent on countless fortunate accidents, the right kind of star, the right planetary mass, the right moon, the right magnetic field, the right distance from galactic hazards, that Earth-like worlds are vanishingly rare. But other scientists look at that explanation and find it unsatisfying. Even if only 1 in a billion worlds produces intelligent life, the numbers are so large that we should still expect millions of technological civilizations in the observable universe, unless something else is happening. In 1998, economist Robin Hanson proposed a concept that cuts to the heart of our situation. He called it the Great Filter. The idea is simple and terrifying. Somewhere between lifeless matter and a galaxy-spanning civilization, there must be at least one step that is almost impossibly difficult to pass, a filter so severe that it prevents almost all life from reaching the stars. The question is where the filter lies. If it is behind us, if the hard step is the origin of life itself, or the transition from single-celled to multicellular organisms, or the evolution of intelligence, then we have already passed through it. We are the lucky ones. The silence of the cosmos means we are rare and precious, survivors of an improbable gauntlet. But if the filter is ahead of us, the implications are much darker. It would mean that civilizations routinely reach our level of development and then somehow fail. They destroy themselves, they go extinct, they encounter something that wipes them out, and we are next in line. This is why some scientists say we should hope not to find life on Mars or Europa or anywhere else. Every time we discover that life emerges easily, that intelligence evolves readily, we push the great filter further into our future. We make it more likely that whatever destroys civilizations is something we have not yet faced. But there is another possibility, one that does not require mass extinction or cosmic catastrophe. What if advanced civilizations are out there, countless millions of them, and they have simply chosen not to speak to us? What if they are watching in silence? In 1973, a radio astronomer named John Allen Ball at MIT proposed an idea so strange, so anthropologically uncomfortable that it divided scientists who heard it. He called it the zoo hypothesis. Ball began with a simple premise. Extraterrestrial intelligent life, he argued, may be almost ubiquitous in the universe. The silence we observe is not evidence of absence. It is evidence of policy. Advanced civilizations, Ball suggested, have deliberately chosen to isolate humanity. They observe us from a distance, like visitors to a nature preserve, but they do not intervene. They do not make contact. They have placed Earth inside a metaphorical cage, one-way bars that allow them to see us while we cannot see them. We are zoo animals, and we do not even know it. Ball was careful to present his hypothesis as one possibility among many. He acknowledged that it was speculative. He noted the difficulties in testing it, but he also argued that it was consistent with everything we observe, or fail to observe, about the universe. The hypothesis has a certain logical elegance. It explains the great silence without requiring that intelligent life be rare. It explains why SETI has found nothing without requiring that no one is transmitting. It explains the absence of evidence without claiming that evidence should be easy to find. Ball's paper appeared in the journal Icarus, one of the most respected publications in planetary science. It was not dismissed as fringe speculation. It was discussed, debated, cited. Other scientists built on it, refined it, proposed variations. The zoo hypothesis had entered the scientific conversation, and it has never left. The idea sounds like science fiction. It sounds paranoid, narcissistic even. The notion that the entire galaxy has agreed to leave humanity alone. But as a solution to the Fermi Paradox, it has a strange and uncomfortable logic. Think about what we know of ourselves. When humans encounter less advanced cultures, history tells us what happens. The arrival of Europeans in the Americas did not go well for the indigenous peoples. The pattern repeats throughout human history. Technologically superior civilizations exploiting, conquering, or inadvertently destroying those they encounter. We have also learned, perhaps too late, the value of preservation. We set aside wilderness areas. We protect endangered species. We build zoos and nature reserves, places where animals can live without human interference. We have come to understand that observation without intervention has value, that allowing ecosystems to develop on their own terms teaches us things we could never learn by disrupting them. If we have learned this lesson in a few centuries of scientific thinking, imagine what a civilization millions of years more advanced might understand. Imagine how they might view a young species just beginning to look up at the stars. They might see us as we see chimpanzees in a forest reserve, fascinating, worth protecting, but not yet ready for contact, not yet ready to join the conversation. The zoo hypothesis rests on several assumptions that scientists have debated for 50 years. But as you examine each objection, something curious happens. The arguments against it begin to dissolve. Critics immediately asked, how could you possibly get an entire galaxy to agree on anything? Even here on Earth, nations cannot coordinate on basic questions of diplomacy. How could thousands or millions of alien civilizations maintain a consistent policy of non-interference across billions of years? In 2016, astronomer Duncan Forgan at the University of St Andrews in Scotland decided to test this objection mathematically. He built a computer simulation to model how civilizations might spread and communicate across the galaxy. His findings were surprising. Forgan discovered that if the number of civilizations exceeds around 500, and if those civilizations are long-lived, something interesting happens. They begin to form clusters, groups of civilizations in causal contact with each other, able to exchange information and agree on policies before interacting with newcomers. More importantly, Forgan found that if just one of these clusters established dominance early in the galaxy's history, a hegemonic order could persist. A first civilization emerging billions of years before any others could set the rules. Their traditions, their prohibitions, their ethical principles could become the foundation for all galactic society that followed. Think about that. A single civilization arising 8 or 10 billion years ago could have spread throughout the entire Milky Way before Earth even formed. They could have established protocols for dealing with emerging intelligences. They could have, quite literally, written the rules. And if that first civilization valued something like what we might call biodiversity, the preservation of unique evolutionary pathways, the protection of young species from interference, their preferences could have become galactic law, not through force necessarily, but through the accumulated weight of tradition passed down across millions of successor civilizations. A cultural heritage so old and so universal that no one questions it anymore. This is not as strange as it sounds. Consider how our own cultural values propagate. Ideas about human rights, about scientific methodology, about ethical treatment of other species. These emerge in specific places and times, but they spread. They become normalized. After enough generations, people follow them without remembering why. A galactic civilization might not need police or military force to maintain a zoo around Earth. They might simply need consensus. The agreement of enough players that interference is wrong, is taboo, is simply not done. The anthropologist would recognize this pattern. The sociologist would nod. We enforce countless behaviors not through law, but through social pressure, through shared understanding of what civilized beings do and do not do. If every civilization that joins the galactic community inherits this principle, if non-interference is presented as the price of membership, the sign of maturity, the mark of a species that has earned its place among the stars, then maintaining a zoo around every emerging world becomes not just possible, but natural. It becomes what everyone does. It becomes who everyone is. But why would they bother? This is the question that gnaws at the hypothesis. Why would beings vastly more powerful than us, with technology we cannot imagine, care about protecting humanity? What possible value could we have to minds that might be millions of years more advanced? Here is where the hypothesis takes a turn towards something that feels almost religious, or perhaps something deeper than religion. Consider what we value. When we protect a wilderness area, we do not do it because the wilderness can give us anything in return. We do it because we recognize something precious in a natural system developing according to its own rules. We find meaning in the existence of wild rivers, ancient forests, species that have never been touched by human hands. We understand that some things are valuable simply because they exist. Now imagine a civilization that has existed for hundreds of millions of years. A civilization that has mastered every technology we can imagine and countless technologies we cannot. A civilization that has perhaps exhausted the possibilities of material expansion and turns instead to questions of meaning, of purpose, of what makes existence worthwhile. What would be rare to such a civilization? Stars are everywhere. Planets are common. Even life, microbial life, might prove to be abundant once we learn where to look. But intelligence, consciousness, the strange miracle of matter waking up and contemplating itself, that might be genuinely rare. That might be the universe's greatest treasure. And if you are the custodian of such a treasure, if you have found countless worlds where the spark of awareness flickers into being, you might come to see each one as infinitely precious, each one as a unique experiment, a novel solution to the question of how minds can arise. Would you risk contaminating that experiment? Would you introduce yourself before the young species was ready, knowing that your very presence would reshape everything that followed, that they would never develop their own answers, their own culture, their own way of being in the cosmos? Or would you wait? Paul himself suggested that diversity might be the key value that advanced civilizations, having seen the same patterns repeat across countless worlds, might hunger for something genuinely new. And the only way to get something new is to allow it to develop without interference. Each isolated world becomes a laboratory. Each young civilization becomes a unique data point. And humanity, sealed inside our invisible enclosure, becomes something precious precisely because we do not know we are being studied. We are developing our own culture, our own technology, our own answers to the great questions, uncontaminated by the knowledge that would reshape everything if it were given too soon. There is a darker variant of the hypothesis. Ball mentioned it himself, calling it morbid and grotesque. What if we are not a nature preserve? What if we are a laboratory? What if the beings watching us are not motivated by preservation, but by experimentation? What if Earth is a petri dish and we are the culture growing inside? This version of the zoo hypothesis does not require benevolence. It requires only curiosity. The desire to see what happens when a species like humanity faces certain challenges. How do they respond to nuclear weapons, to artificial intelligence, to climate change, to the discovery that they are being watched? Under this interpretation, our history might not be entirely our own. The watchers might be running simulations, testing variables, perhaps even introducing stimuli to see how we respond. Not because they care about us, but because they want to understand something about the development of intelligence itself. This is the interpretation that keeps some scientists awake at night, because it suggests that our situation might be not just isolating, but controlled. That the great filter might not be a natural phenomenon, but an imposed one. That the watchers are waiting to see if we pass a test, and what happens if we fail. The philosopher Stephen Baxter went even further. In 2001, he proposed what he called the planetarium hypothesis. Perhaps, he suggested, we are not merely being observed. Perhaps the observable universe itself is a simulation constructed around us, a cosmic Truman show, designed to make us believe we are alone, when in fact, the walls of our enclosure extend in every direction, painted with stars that do not exist. The physics of such a simulation would be challenging, but not impossible, for a sufficiently advanced civilization. And it would explain not only the great silence, but also certain puzzling features of our reality. The cosmic speed limit that prevents us from exploring too far. The quantum uncertainties that might be computational artifacts. The strange fine-tuning of physical constants that make life possible at all. Under this interpretation, we would never find evidence of alien life because there is no alien life to find. Everything we observe has been constructed for our benefit. We are, quite literally, characters in someone else's story. Most scientists consider this unfalsifiable and therefore unscientific. But the mere possibility haunts the edges of serious discussion. Because if it were true, how would we ever know? The Chinese science fiction author Liu Cixin offered yet another vision of what the Watchers might be thinking. In his novel, The Dark Forest, published in 2008, he proposed that the universe operates like its title suggests, a dark forest filled with armed hunters, each one stalking through the trees, terrified to reveal their position. Liu's hypothesis rests on 3 axioms. First, survival is the primary need of every civilization. Second, civilizations grow and expand, but the matter and energy in the universe are finite. Third, there is no way to know if another civilization is benevolent or hostile. What Liu calls the chain of suspicion. In the dark forest, discovery means death. Any civilization that reveals itself will be destroyed by others who cannot risk the possibility that the newcomer might one day become a threat. The only rational strategy is silence. Hide, wait, and if you detect someone else, strike first. This is not the zoo hypothesis, but it intersects with it in unsettling ways. Under Liu's model, advanced civilizations would also be silent, but not because they want to protect us, because they are afraid of each other, afraid that making contact with humanity might reveal their own position to something else out there. Perhaps the Watchers are not zookeepers, but fellow prey, hiding in the same forest, knowing that to speak is to die. The late physicist Stephen Hawking seemed to take this possibility seriously. In his 2010 documentary series, he warned against the dangers of making contact with alien civilizations. If aliens visit us, Hawking said, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. He repeated this warning throughout his life. In 2016, meeting an advanced civilization could be like Native Americans encountering Columbus. That didn't turn out so well. Hawking supported the search for extraterrestrial intelligence. He helped launch the Breakthrough Listen project. But he was deeply skeptical about the wisdom of announcing our presence, of shouting into a forest when we do not know what else is listening. So where does this leave us? We have a paradox. The universe should be full of intelligence, but we see no evidence of it. We have a hypothesis. Advanced civilizations might be watching us without making contact. We have objections, but the objections have answers. We do not know if the zoo hypothesis is true. We cannot know, perhaps not for centuries, perhaps not ever. The very nature of the hypothesis makes it difficult to test. If the Watchers are sufficiently advanced, they could hide from any instrument we might build. But some scientists have proposed ways we might investigate. In 2010, Douglas Vakoch, then at the SETI Institute, suggested that we could attempt to break out of the zoo by sending intentional signals into space. Not passive listening, but active messaging, what is now called METI, messaging extraterrestrial intelligence. The logic is simple. If the Watchers are waiting for us to demonstrate awareness, waiting for us to signal that we are ready for contact, then the way to break the silence is to speak, to show that we know they might be there, to ask explicitly for a response. In 2017, Vakoch's organization transmitted a message toward Luyten's star, a red dwarf just 12 light years away. The message included mathematical and scientific information, music, and an explicit invitation to respond. If anyone is listening, we might hear back by 2041. But the idea of messaging has critics. David Brin, an astronomer and science fiction author, has argued that transmitting powerful signals into space is reckless. If the dark forest hypothesis is correct, we might be painting a target on our planet. Others argue that the debate is moot. Earth has been leaking radio and television signals into space since the 1930s. Our electromagnetic footprint expands at the speed of light in all directions. If anyone within 100 light years has the technology to detect us, they already know we are here. The zoo, if it exists, has already accounted for our signals. The watchers have already heard us cry out. They have simply chosen not to respond. Let us assume for a moment that the zoo hypothesis is true. What would that mean for us? It would mean that we are not alone. That consciousness, intelligence, mind, these are not accidents, not flukes, but features of the universe that emerge wherever conditions allow. It would mean that our species is part of a vast family of thinking beings scattered across the cosmos. It would also mean that we are not yet members of that family, not yet mature enough, wise enough, evolved enough to join the conversation. We are children, protected from knowledge we are not ready to handle. This could be humbling. It could be infuriating. It could reshape every religion, every philosophy, every assumption we have ever made about our place in existence. But here is the strange thing. It might also be hopeful. If the watchers exist, if they have maintained their vigil for millions or billions of years, then they have already survived every danger we fear. They have passed through the filter, nuclear weapons, artificial intelligence, climate catastrophe, whatever else destroys young civilizations. They have proven that it is possible to endure. And if they are protecting us, it suggests they believe we can endure too, that we are worth preserving, that the experiment of humanity has value, has potential, has something to contribute to the cosmic community that will one day emerge from our isolation. The silence under this interpretation is not abandonment, it is trust. The watchers are giving us room to grow, to make our own mistakes, to find our own way to the stars. One day, perhaps, we will be ready. We will develop the wisdom that comes with survival, the maturity that comes with facing our demons and overcoming them. We will reach out, not in desperation, but in confidence, ready to meet whatever is waiting on the other side. And then, the bars of the cage will open, the watchers will introduce themselves, and humanity will take its first steps into a universe far more crowded, far more ancient, and far more strange than we ever imagined. Or perhaps we are wrong about all of this. Perhaps the silence is real. Perhaps we are alone. Perhaps the zoo is empty except for us. And the question, where is everybody, has the simplest and saddest possible answer. There is nobody else. We cannot know. We may never know. The universe keeps its secrets. But consider this. We are the species that looked up at the stars and asked the question. We are the ones who built radio telescopes and sent probes to distant planets and decoded the structure of the atom. We are the ones who imagined gods and ghosts and extraterrestrials, populating the cosmos with minds because we could not bear to think it empty. Whether or not the watchers exist, we have become watchers ourselves. We observe the universe. We ask questions. We search for patterns. We wonder, and in a cosmos that might be filled with silence, that wondering is itself a kind of miracle. Perhaps we are zoo animals. Perhaps we are laboratory specimens. Perhaps we are the first and only minds to ever emerge from the cosmic dark. But we are here. We are aware. We are reaching out. And somewhere, somehow, something might be reaching back. The cage door, if it exists, does not have to stay closed forever. We just have to prove we deserve the key. When you next look up at the night sky, remember this. Those stars have been shining for billions of years. Countless worlds orbit them, worlds with oceans and mountains, and perhaps somewhere, minds looking back at you. The universe is old enough and large enough to contain multitudes, and yet you see only darkness. You hear only silence. That silence might be emptiness, the absence of companions in an indifferent universe, or it might be the greatest courtesy ever extended to our species, the gift of time, the chance to become something worthy of contact. The watchers, if they are there, are patient. They have waited millions of years. They can wait a little longer. The question is not whether they will reveal themselves. The question is whether we will be ready when they do. End of script word count. Approximately 4,850 words. Note, this is approximately half the target length. The script continues below with additional chapters to reach the 10,000 word target. Think about what it means to be observed without your knowledge. Every moment of your life, every decision you make, every triumph and failure and mundane afternoon, catalogued by intelligences you cannot perceive. They watch your species wage wars and make peace. They watch you fall in love and grieve your dead. They watch you build cathedrals and concentration camps, write symphonies and commit atrocities. What do they think of us? This is perhaps the most unsettling aspect of the zoo hypothesis. Not the watching itself, but the judgment that must accompany it. If beings vastly more advanced than us have been observing humanity for millennia, they have formed opinions. They have reached conclusions. They know things about us that we do not know about ourselves. Consider the experiments we conduct on other species. When scientists study animal behavior, they do not merely observe, they evaluate. They measure intelligence, assess problem-solving ability, test for cooperation and competition and cruelty. They try to understand what kind of creature they are dealing with. The watchers would have done the same. They would have seen the pattern of human history, the rise and fall of empires, the inventions that elevated us and the weapons that nearly destroyed us. They would have watched us split the atom in 1945 and hold our breath for decades, wondering if we would use our new power to annihilate ourselves. We did not, at least not yet. What did they conclude from that? Were they surprised that a species so young and violent managed to restrain itself? Or is this a test that many species pass, one of many checkpoints on the road to maturity? We do not know what the criteria are. We do not know what they are looking for. Perhaps technological advancement, perhaps ethical progress, perhaps some quality we cannot even name, a form of wisdom or compassion or cosmic citizenship that we have not yet developed. The zoo hypothesis suggests that contact will come when we are ready. But ready for what? By whose standards? There is a concept in science fiction that captures something important about this situation. It appeared in Star Trek and has become a touchstone for discussions about extraterrestrial ethics, the Prime Directive. In the fictional Star Trek universe, The Prime Directive is Starfleet's highest law. It prohibits interference with the natural development of any alien civilization, particularly those that have not yet developed faster than light travel. Starfleet officers are forbidden from revealing themselves to pre-warp species, sharing advanced technology, or influencing the course of their societies in any way. The principle sounds noble in theory. It respects the autonomy of developing civilizations. It protects them from becoming dependent on superior technology they did not earn. It allows cultures to make their own mistakes and find their own solutions. But the show repeatedly dramatizes the moral cost of non-interference. In one episode, the Enterprise crew watches an entire civilization perish from natural disaster, refusing to intervene because the people are not yet advanced enough to know aliens exist. The Prime Directive, taken seriously, demands that Starfleet officers allow genocide and extinction rather than reveal themselves. If the Watchers operate under something like the Prime Directive, the implications are profound. They would have observed every horror in human history without intervening. The Black Death killing a third of Europe's population, the transatlantic slave trade, the Holocaust, every war, every famine, every preventable suffering. They watched. They did nothing. From our perspective, this seems monstrous. How could beings with the power to help simply observe while millions died? But consider how we treat the natural world. When predators kill prey in a nature reserve, we do not intervene. When disease sweeps through a population of wild animals, we often let it run its course. We believe, perhaps correctly, that interference would cause more harm than good in the long run, that ecosystems function best when left alone. The biologist Jane Goodall spent decades observing chimpanzees without intervening in their lives. She watched them wage war against each other. She watched them kill infants of rival groups. She watched suffering that she had the power to prevent. And she did not intervene, because intervention would have corrupted the very thing she was trying to understand. The Watchers might see human suffering the same way. Tragic, yes. Painful to observe, but necessary for our development. A species that is rescued every time it faces crisis never learns to rescue itself. There is precedent for this kind of thinking even in human ethics. We allow children to struggle with problems we could easily solve for them, because we know that the struggle itself builds capacity. We let teenagers make mistakes that hurt them, because protecting them from all consequences prevents them from developing judgment. Perhaps the Watchers view humanity as a kind of adolescent species, old enough to face real dangers, young enough to learn from them, at exactly the stage where interference would stunt our growth rather than help it. This is cold comfort. It is not supposed to be comfortable. But if the zoo hypothesis is true, it forces us to confront an uncomfortable possibility, that what we would consider divine intervention, an advanced civilization would consider contamination, that our suffering is the price of our autonomy. Some scientists have tried to estimate when the zoo hypothesis might be tested, when humanity might become advanced enough that the Watchers could no longer hide from us. One analysis suggests this could happen within the next 50 years. As our telescopes grow more powerful, as our ability to detect techno-signatures improves, the hiding places available to advanced civilizations shrink. If there are megastructures in our galaxy, Dyson spheres harvesting the energy of entire stars, for example, we should eventually be able to see them. If there are signals being exchanged between civilizations, our instruments may become sensitive enough to detect the leakage. At some point, concealment becomes impossible, and when that happens, the watchers face a choice: reveal themselves deliberately, on their own terms, or be discovered, caught out, exposed. Perhaps this is what they are waiting for. Not a moral test, but a technological one. The moment when we develop the capability to see them anyway, at which point silence becomes pointless. Under this interpretation, the zoo is temporary. It has an expiration date, and we are closer to that date than we have ever been. The James Webb Space Telescope, launched in 2021, can analyze the atmospheres of exoplanets, searching for biosignatures that might indicate life. The Nancy Grace Roman Space Telescope, scheduled for the late 2020s, will survey a far larger area of the sky. Future observatories, like the proposed Habitable Worlds Observatory, will be specifically designed to find and study Earth-like planets. Within our lifetimes, we might confirm that life exists elsewhere. We might detect the chemical signatures of biology on a distant world, and that discovery would change everything. Because once we know life is not unique to Earth, the question becomes unavoidable. Where are the civilizations? If life is common, intelligence should eventually be common too. And if intelligence is common, technology should follow. The zoo walls would begin to crack, and what lies beyond them would finally come into view. But there is another way this could unfold. What if the watchers do not wait for us to find them? What if, under certain conditions, they decide to make contact? Douglas Vakoch, president of METI International, has argued that the zoo hypothesis contains within it a path to first contact. If the aliens are waiting for us to signal our readiness, then the way to trigger contact is to send the signal. This is not passive listening. This is deliberate, directed communication. Messages beamed at specific stars where we have reason to believe habitable planets exist. Mathematical patterns that could not arise naturally. Explicit invitations to respond. In 2017, Vakoch's organization did exactly this. They transmitted a message to GJ273, a red dwarf star 12 light-years away with at least 2 planets, one of which sits in the habitable zone. The message contained basic physics and mathematics, followed by music, followed by a request. Please answer. If anyone received it, if anyone understood it, they would know we are aware of them. They would know we are asking for contact. And if the zoo hypothesis is correct, if they have been waiting for this precise moment, they might respond. The round-trip time for a signal to GJ273 is about 25 years. If Vakoch's message was received and answered immediately, we could hear back by 2042. If it takes longer to compose a response, if there is debate among the watchers about whether to break the silence, it could be later. But the clock is ticking. For the first time in human history, we have actively announced ourselves to a specific, potentially inhabited world. We have done what a zoo animal might do if it suddenly realized it was being watched. We have looked up at the observers and asked to be let out. Not everyone thinks this was wise. The debate over METI, whether humanity should actively transmit messages into space, has become one of the most contentious in astrobiology. On one side are those like Vakoch, who argue that signaling is the logical next step in our search for extraterrestrial intelligence. We have been listening for over 60 years with no result. Perhaps the problem is not that no one is transmitting. Perhaps The problem is that everyone is listening and no one is speaking. Someone has to break the silence first. On the other side are scientists and public figures who warned that transmitting could be catastrophically dangerous. Stephen Hawking was the most prominent voice in this camp, but he was not alone. The arguments against METI echo the fears embedded in the dark forest hypothesis. We do not know what is out there. We do not know if the watchers are benevolent or predatory. We do not know if making contact would be an invitation to friendship or a beacon that draws something terrible to our doorstep. In 2015, a group of scientists, including Berkeley astronomer Andrew Semyon, released a statement urging caution. A worldwide scientific, political, and humanitarian discussion must occur before any message is sent, they wrote. The stakes are too high for any individual or organization to make the decision unilaterally. But the critics of METI face a practical problem. Earth has been leaking electromagnetic radiation into space since the early 20th century. Our radio broadcasts, our television signals, our radar, all of it travels outward at the speed of light, an expanding bubble of noise that now extends over 100 light years in every direction. If there are watchers, they already know we are here. The message has already been sent accidentally over the past century. METI simply makes the communication intentional rather than inadvertent. The zoo, if it exists, knows exactly where its exhibits are located. Sending another message changes nothing fundamental about our situation. Or does it? Some argue that there is a difference between the low power leakage of normal radio transmission and the focused, high power beam of a deliberate METI signal. Our accidental broadcasts fade rapidly with distance. A directed message does not. It screams across the void in a way that television static never could. Perhaps the watchers have a threshold, a level of intentional signaling that triggers a response or triggers something else. Perhaps by deliberately transmitting, we are crossing a line we cannot uncross. We do not know. We cannot know. This is what makes the debate so fraught. We are gambling with the fate of our species on incomplete information about the intentions of beings we have never met. The philosopher Nick Bostrom, known for his work on existential risk and the simulation argument, has suggested another way to think about our situation. Perhaps, he argues, we are living in one of many possible universes. In some of them, young civilizations make contact with advanced ones and thrive. In others, contact leads to destruction. In still others, civilizations remain isolated forever. We do not know which universe we inhabit. We cannot know until we try. And the trying itself shapes the outcome. This is a form of what philosophers call decision theory under uncertainty. When you do not know the probabilities, when you cannot estimate the risks, you fall back on other criteria. Which choice is most reversible? Which outcome is most regrettable? What decision would you make if the worst-case scenario came true? For METI, the analysis is troubling. If we transmit and attract hostile attention, the outcome is extinction, an irreversible catastrophe. If we transmit and make contact with benevolent civilizations, the outcome is wonderful, but perhaps not much different from eventually making contact through passive means. If we stay quiet and the watchers are benevolent, we lose nothing but time. They will eventually reveal themselves, or we will eventually find them. If we stay quiet and the watchers are hostile, our silence protects us. Our camouflage holds. Under this logic, caution seems rational. The asymmetry of outcomes favors waiting. The cost of being wrong about benevolence is higher than the cost of being wrong about patience. But this analysis assumes we have time. It assumes the watchers will wait forever. It assumes there is no deadline, no test, no threshold we must reach before an opportunity closes. If the zoo hypothesis is true, neither assumption may hold. Perhaps the final question is not about the watchers at all. Perhaps it is about us. What kind of species do we want to be? We could be cautious. We could hide. We could keep our heads down and hope that whatever is out there does not notice us. We could accept our enclosure, grateful for its protection, and wait for the day when the zookeepers decide we are ready for the wider world. Or we could be bold. We could announce ourselves. We could reach out across the void and declare that we are here. We are aware. We are not afraid. We could take the risk that our ancestors took when they left the savannah, when they crossed the oceans, when they split the atom, the risk of the unknown. Both paths are defensible. Both reflect genuine values, prudence versus courage, security versus discovery. The zoo hypothesis does not tell us which path to choose. It only tells us that the choice may matter more than we ever imagined. Look at the stars one more time. 400 billion of them in our galaxy alone. 2 trillion galaxies in the observable universe. Numbers so large they lose meaning, become abstract, dissolve into poetry. Somewhere among those countless points of light, minds may be contemplating us, watching our planet spin through its fragile orbit, waiting for the day when we emerge from our cocoon and take our first uncertain steps into the dark. Or perhaps not. Perhaps the silence is real. Perhaps the cosmos is empty except for us, and the question has no answer, because there is no one to answer it. Either way, we are the species that asked. That is our glory. That is our burden. That is the thing no isolation can take away. The watchers, if they exist, know this. They have seen countless species arise and question and reach. They know the pattern. They know where it leads. They are patient because the universe is patient. Time moves differently for minds that span epochs. But for us, time is precious. Time is short. We have a window, this moment, to decide what kind of story we want our species to tell. A story of caution, of waiting, of deference to powers we do not understand. Or a story of reaching, of risking, of stretching out our hands towards something that might destroy us or might transform us into something we cannot yet imagine. The zoo hypothesis does not answer this question. It only makes the question real. And now, perhaps for the first time, you understand why certain scientists cannot sleep at night. The bars of the cage are invisible, but they are there. The question is not whether we are being watched. The question is what we do about it. There is one more possibility we have not fully explored. One more twist in this cosmic mystery that demands our attention. What if the zoo is not about protection at all? What if it is a test? Consider how we evaluate other species. When scientists want to understand the intelligence of an animal, a crow, an octopus, a chimpanzee, they design tests, puzzles to solve, obstacles to overcome, rewards to earn. The tests reveal what the animal is capable of, but they also reveal something deeper. What kind of intelligence the animal possesses? Is it patient or impulsive? Cooperative or competitive? Creative or rigid? Does it give up when faced with difficulty, or does it persist? Now imagine that Earth is the test, that human civilization is the puzzle, and that the Watchers are evaluating not just whether we can solve it, but how we solve it. The challenges we face, nuclear weapons, climate change, artificial intelligence, pandemics, are not accidents. They are not cosmic bad luck. They are the test conditions, the variables deliberately introduced to see what we will do. This interpretation of the zoo hypothesis is darker than the others. It suggests that our suffering is not merely observed but designed, that the Watchers are not passive naturalists but active experimenters, that every crisis humanity faces is data they are collecting, but it also suggests something hopeful. If the challenges are tests, then they can be passed. If the Watchers are evaluating us, then there is a standard we can meet. If Earth is a puzzle, then there is a solution. The question becomes, what are they testing for? Perhaps they want to know if a species can develop weapons of mass destruction and choose not to use them. We have done this, at least so far. The Cold War ended without nuclear exchange. 75 years after Hiroshima, no nuclear weapon has been used in war. Perhaps they want to know if a species can recognize an existential threat to its biosphere and act to prevent it. We are still being tested on this one. Climate change is accelerating. Our response has been inadequate. The verdict is not yet in. Perhaps they want to know if a species can create artificial intelligence and remain in control of it. This test is just beginning. The next few decades will determine whether we pass or fail. Perhaps they want to know if a species can achieve global cooperation, overcoming nationalism, tribalism, the ancient divisions that have defined human history. We have made progress here, but the project remains unfinished. Each crisis is a question. Our response is an answer. And the Watchers, if they exist, are keeping score. The evolutionary biologist would recognize this pattern. Natural selection does not test organisms once and then leave them alone. It tests them continuously, generation after generation, crisis after crisis. The tests never stop. The species that pass survive. The species that fail go extinct. Perhaps cosmic selection works the same way. Perhaps the reason we see no evidence of other civilizations is not that they never existed, but that they failed their tests. They developed nuclear weapons and used them. They created AI and lost control. They destroyed their biospheres and went extinct. The great filter under this interpretation is not a single event, but a series of exams, each one more difficult than the last, each one eliminating more candidates from the cosmic competition. And the Watchers are the proctors, the administrators of an admissions process for galactic civilization. They observe, they record, they wait to see who makes it through. Humanity is somewhere in the middle of the exam. We have passed some tests. Others we are still taking. Still others lie ahead. Challenges we cannot yet imagine. The silence of the universe might be the silence of a testing room. Everyone is focused on their own problems. No one is allowed to share answers. And the proctors do not speak until the exam is over. There is a certain comfort in this interpretation. It suggests that our struggles have meaning, that the difficulties we face are not random cruelty, but purposeful challenges, that success is possible, and that success would be rewarded. But there is also terror, because tests can be failed, because we do not know the passing score, because the consequences of failure might be extinction, not just for humanity, but for every form of life on Earth. The Watchers, if they exist, have seen species fail before. They have watched civilizations rise to the threshold of galactic maturity and then destroy themselves. They have observed, recorded, analyzed, and they have let it happen. Non-interference is the rule. The test must be fair. No help from outside. No second chances. This is what the Fermi Paradox might really be telling us. Not that intelligent life is rare, but that intelligent life that survives is rare. The filter is severe. Most do not pass. And we are taking the test right now. What would it mean to pass? If the watchers are real, if the test is real, what does victory look like? Perhaps it looks like this: a species that masters the technologies capable of destroying it and instead uses them for flourishing. A species that extends its presence beyond its home world, becoming resilient against planetary catastrophes. A species that achieves something like wisdom, the ability to balance power with responsibility, knowledge with humility. Perhaps passing the test means not just surviving but maturing, growing beyond the adolescent phase of technological civilization where power outstrips judgment, reaching an adulthood where we can be trusted with the universe. The watchers, if this is their purpose, are not merely observing. They are waiting to see if we will grow up, waiting to welcome us if we do. And if we fail, then the test moves on. Another world, another species, another chance for the universe to produce minds worthy of the stars. We would be a footnote, a data point in an experiment that spans billions of years, a promising candidate that ultimately did not make the cut. The silence would continue. For someone else, the cage would remain. But here is the thing about tests. They are only meaningful if they can be passed. If the universe has been running this experiment for billions of years, if countless civilizations have faced these challenges before us, then some of them must have succeeded. The test cannot be so hard that no one ever passes. Otherwise, there would be no watchers at all. The existence of the zoo implies the existence of the zookeepers. And the existence of the zookeepers implies that someone, somewhere, at some point, graduated from the enclosure. They faced the challenges we face. They navigated the dangers we navigate. They emerged from their own testing period and took their place among the stars. And now, they watch us trying to do the same. Perhaps they remember their own struggle. Perhaps they feel sympathy, kinship, hope for our success. Perhaps they are rooting for us, even as they are forbidden from helping. Or perhaps they are simply curious. Perhaps, after billions of years of existence, curiosity is the only thing that still motivates them. The curiosity to see how each new experiment unfolds, how each young species responds to the challenges that define its moment in cosmic history. We are their entertainment. We are their ongoing research project. We are the reason they built the zoo in the first place, not to contain us, but to observe us, to learn from us, to see what new solutions we might discover to the old problems that every civilization faces. Under this interpretation, the watchers are not judges. They are students, and we are their subject matter. This is the most optimistic reading of the zoo hypothesis. Not just that we are being watched, but that we are being watched by beings who once were where we are now, who know what it takes to survive, who believe we can do it. The silence is not indifference, it is faith. Faith that we will figure it out. Faith that we will find our way through the darkness. Faith that the same evolutionary pressures that produced intelligence on countless other worlds will guide us towards survival on ours. And if the Watchers are wrong, if their faith is misplaced, if humanity stumbles and falls, destroys itself, joins the long list of failed experiments, then they will mourn, perhaps. They will record what happened. They will analyze our mistakes, and they will move on, because the universe is vast, and other worlds are waiting, and the experiment never really ends. In 2019, scientists gathered in Paris at a meeting devoted to SETI and related topics. Among the subjects discussed was the zoo hypothesis and its implications. Florence Rollin-Cerceau, a MIT researcher, noted something interesting about the conversation. For decades, the hypothesis had been dismissed as fringe, as unfalsifiable, as uncomfortably close to science fiction. But as the Fermi Paradox deepened, as we discovered more and more habitable planets while hearing nothing from them, the zoo hypothesis began to seem less like speculation and more like a serious possibility. The puzzle of why we haven't detected extraterrestrial life has been discussed often, Cerceau said. But in this workshop's unique focus, many of the talks tackled a controversial explanation first suggested in the 1970s. The hypothesis is no longer laughable. It is no longer dismissed out of hand. It is discussed in peer-reviewed journals, at scientific conferences, by serious researchers trying to understand the silence of the cosmos. This represents a shift in scientific culture, a willingness to consider ideas that would have seemed absurd a generation ago, a recognition that when confronted with profound mystery, we must expand the range of possibilities we are willing to entertain. The universe has surprised us before. It has turned out to be larger, stranger, and more wonderful than our ancestors imagined. Perhaps it will surprise us again. So where does this leave you? You have heard the question that keeps astronomers awake at night. You have explored the hypothesis that offers one possible answer. You have considered the implications, the objections, the variations that make the idea even stranger. You do not know if the zoo hypothesis is true. Neither do the scientists. Neither does anyone. The silence persists. The mystery remains. But you know something now that you did not know before. You know that the universe might be watching. You know that the silence might be meaningful. You know that humanity might be taking a test we do not fully understand. And you know that the outcome might depend on us, not on technology, not on luck, on us, on the choices we make, on the kind of species we decide to become. The Watchers, if they are there, cannot tell us what to do. The rules forbid it. The test requires that we figure it out ourselves. But the stars are patient. Time is long. And the cage door, somewhere in our future, might be waiting to open. There is one more thing. In John Ball's original 1973 paper, buried in the scientific language and careful qualifications, there is a sentence that haunts the imagination. Extraterrestrial intelligent life may be almost ubiquitous. Almost ubiquitous. Everywhere. On world after world. In system after system. Minds looking up at the same stars we see. Thinking the same thoughts. Asking the same questions. All of them silent. All of them waiting. All of them watching the young species on a small planet in an unremarkable corner of an ordinary galaxy, wondering what we will do next. The universe is vast. The silence is deafening. The mystery is profound. But you are part of the story now. You are one of the beings being watched. And what you do with that knowledge, how you live, what you choose, who you become, might matter more than you ever imagined. The Watchers are patient. but they are paying attention. And somewhere, in the spaces between the stars, the great experiment continues. The question is not whether you will be part of it. You already are. The question is what role you will play. Whether your species will be remembered as one that passed the test, or as one more data point in a very long study of what happens when young civilizations encounter their limits. The choice, in the end, is yours. Not the watchers, not the cosmos. Yours. Look up at the stars tonight. Really look. Let the enormity of what you are seeing settle into your bones. Billions of years, trillions of worlds, countless minds perhaps, contemplating the same sky from their own enclosures. You are part of something vast, something ancient, something that may be watching to see what you do next. Do not disappoint them.